okay, when I have hypersthenic type patients and I have my normal techniques, then I usually, at the very least, double the mass, double the MA or double the time. So doubling the MA would be better, wouldn't it? Yeah, you can. I would go up probably no more than 10 kV. Do both. And 10 kV is around 15% for your medium range. But yeah, there's times I've done both. You know, doubled the MA, go up 10, 15 on the kV. Certainly have done that. And sometimes that hasn't worked. So it just depends. Have you ever done a lateral lumbar spine on a hypersthenic patient?
Yes.
All the time.
And what was your technique?
It's almost the same as the AP.
Almost the same as the AP?
Because they're round on all sides.
All the way around.
When you have a thinner patient, that's when it actually goes up more from AP to lateral.
One of your higher techniques will be the lateral lumbar spine. We always had trouble. Usually that type of person with that kind of back problem, we would do, it's great if you can roll them up on their side, but a lot of times they were on a backboard maybe because they fell and hurt themselves. And so we shot, it's not really a decubitus, but cross table. And the problem was, so we'd have the gridded cassette here, and then the x-rays would go through, hit the wall, and come back. That's how high of a technique we were using. And so we got some lead and put it on the back of the cassette. We had 2 little hooks and draped some lead on the back of the cassette to absorb the scatter coming back from the wall. I mean, but anyway, let's talk about filtration. How does filtration affect the beam quality? It increases it. Okay, the overall average energy, it hardens the beam. The quality of the beam, it hardens the beam. The average energy is higher. So now we use the half value layer to determine the quality of a beam in an X-ray room. So, okay, so you can have 70 kV in this front room and have 70 kV in the back room. Are you assuming that they have the same energy? GE, Philips, brand new, older. Would you expect it to be the same quality? Probably not. So how do you measure the quality of an X-ray beam? And that's what you do the half value layer for. That is a quality control test that usually the physicist does to determine how strong the X-ray beam is and if it's appropriate or not. So what is the half value layer? It's that amount of absorbing material that reduces the X-ray beam to half is value, or 50% of its intensity. So if you take an X-ray with nothing on top of the ionization chamber, and it reads 100%, and then you add 1 millimeter of aluminum, and it comes down a little bit, another piece of aluminum, another one, until it gets to 50 milli-R. Okay, and then you figure out how much aluminum that is. That is the half value layer, so maybe 4 millimeters of aluminum. So what, okay, so here are, where am I working all right? Here are your 2 rooms. Okay, here are your 2 rooms, room A, room B. Let's say we started off at 95 MR. Let's do 100, 150 here, 40. Okay, so room B, we'll start at 49, 40, 30. Okay, so here you have a room, and you started off at 100 MR here, 50 MR here, at 1 millimeter of aluminum. This is the reading that you, oh, I didn't line those up. How about that? 49. Okay, and then here's 2 millimeters of aluminum, 3. 4, 5, 6, 7 millimeters. Okay, my question to you is, what is the half value layer of room A? 5 millimeters is that amount. So it's the amount is in millimeters. So here's the half value layer for this one. What is the half value layer for room B?
7.
7 millimeters. Which room has the stronger beam? Has a higher quality beam? Which one has a higher quality beam?
B.
B. It took, that beam is so strong that it took more aluminum to get it down to half. Does that make sense? So that's what the half value layer determines, which, given 2 X-ray beams, you know, that's how you find out the quality of the beam. So let me ask you this. As the half value layer increases, the quality of the beam increases. As KV increases, the half value layer. KV increases, meaning it's more penetrating, therefore the half value layer would be increased. So beam quantity, what affects that? These are basic things that you need to know. The primary controlling factor of quantity is mass, but you do have secondary factors, KV, filtration. Remember the different types of filtration in the tube. Inherent is built into the tube. The oil surrounding the X-ray tube, the metal housing, whatever it may be, will add some filtration. Then we'll filtrate the beam, and then we add some of the aluminum for a total amount. So what is the minimum amount here?
1?
Is 0.5. 0.5 millimeters of aluminum equivalent. Added is usually 2 for a total of 2.5. Now everybody, that is minimum. Usually your fluoro rooms or your X-ray rooms at your hospital may have 3 millimeters, but that's minimum amount. And then distance affects quantity, that amount of radiation reaching the film. Inverse, as we talked about, inversely proportional to that. Primary radiation, remnant or exit radiation, image forming X-rays. You may have questions like that on your ARRT exam, so I think you're familiar with these, right? Just some basic terminology. If you're not, make sure you look at those. How does scatter affect the image? How does scatter affect density? It increases density. What does it do to contrast?
Decreases it.
Decreases it. So what effect, how do you control scatter? Collimation, which is the field size. What else do you do?
Grids.
Grids, you can use grids. But that's only the scatter, you know, reaching the image receptor. What else? Can you do anything about this?
Unfortunately, no.
Increase patient fitness. You can do a little bit. Have you ever done this?
Please tell me.
No. If you're, I don't know that you would do this. There's nothing you can do about patient thickness. However, if you're doing an abdomen exam and they're laying on their back, the technique you use for that will be more than if they're laying on their stomach. When any of us lay on our stomach, it spreads out the soft tissue and makes thinner. You can get a compression band, strap it, crank it down. No, but patient thickness affects scatter. How does it affect scatter? The thicker the patient, again, the more scatter we're going to have. That decreases the contrast to potential. What do I mean by that?
KV.
That's the KV. That's the KV. So increasing the KV is going to produce more scatter, and then whatever we're taking an X-ray of can produce more scatter. So bone versus air, bone would produce more scatter radiation than air would. Okay. So all you can do is adjust your kV. If you're at 90 kV, give or take 5 on each side, use the lower kV range as an example if you want to. Collimation will help with that. And then you talked about the use of grid. We certainly use that. Okay. Okay, so let's take a break. Yay. And then we're going to do the clickers. I have review questions over what we